threatening me. Yep, it's recorded now. Thank you. Just want to point out to you guys that your 2 homeworks due this coming tomorrow is 7.1 and 7.2, which we'll go over it today. And then if you have any questions regarding 7.1 and 7.2, either you type on the chat room, or you tell me, just tell me what question. I just write down here. And then your test is next Tuesday. It consists of chapter 6, 6.1 to 6.6, and then also chapter 7, 7.1, 7.2, and 7.3. So today we'll go over 7.3. And also, usually 7.3 homeworks is due on Wednesday, but 7.3 homework is due on Monday midnight. The reason why is because your test is on Tuesday, and 7.3 is a part of the question here. Okay, wow, that's a lot of 7.1. Now, some students ask me about what is going on with, can I have any formulas, anything? The answer is no. In this test, there is no formula allowed. So make sure you know your formula, especially in this chapter 7 sections. You have the what we call as the identities. Remember the identities that you guys do. So make sure you guys know your identities. There's no formula given to you in the test, so you need to know. And sometimes people just memorize this by, just simply memorize it. So I would recommend don't simply memorize. Make sure you also need to know how to apply. Applying is more important. So some students ask me what formula. So this is a formula that I will tell you guys to make sure you guys know how to use this formula. These are the formula in chapter 7.1. And I told you before that Pythagorean identity is used when you see square, right? So every time when you see square in your questions, I will guarantee you guys have to use Pythagorean identity. If you don't see square, then do not use Pythagorean identity. Do not square both sides. Okay, a lot of students try to do that. It makes it more worse. Even odd identity is used when your angle is negative. So if you see any negative in your angle, you use the even odd. The core function is used when you have a 90 degrees minus theta, or pi over 2 minus theta, depends, because 90 degrees and pi over 2 is degrees and radians. So make sure you guys know when we use the core function. And then the reciprocal, I think you guys are very familiar with. Quotient is where you change everything in tangent or cotangent into sine and cosine. So if you want to change everything in terms of sine and cosine, then we will use the quotient identity a lot, because that is how we do tangent and cotangent. Change it to sine and cosine. So so let's take a look at some of the questions here. So we start out with question number 17. Again, this is factoring. So this is something I will tell you guys to do. I want you guys to factor. This is for 17. I want you guys to factor 5x squared minus 8x minus 4. I want you guys to do this. Factor this. If you doesn't know how to factor this, I will just say goodbye. Because the rest of chapter 7, 1, 2, and 3 is a lot of factoring. And if you cannot factoring this kind of factor, I will put you back in algebra 1, which is 3 steps down from this class. So I don't know how you can get into my class if you doesn't know how to factor. So factor this. Yep, we are going through that. Kun, 18 is one of them. Factor 17. You got 2 minutes. I'm going to time you guys 2 minutes to factor this. This is, you're learning algebra 1. You can either put in your chat room, or you can talk to me what is. This is quick. So factor. This and this are exactly the same. I just changed my sine squared to become x squared. That's it. Factoring. I'm going to call names now. I'll be a mean teacher today, actually, because you guys need to know how to do this. Andy, do you know how to factor this one, Andy? Andy Wang? Andy Wang, do you know how to factor this one? Are you there, Andy Wang? Very easy question. And Divine, are you there?
I think I messaged you.
Oh, someone messaged me. Oh, thank you, Andy Wang. I'm sorry I didn't see it. Yep. So sorry about that, Andy Wang. 5x plus 2 and x minus 2. Yep. Now, I want to tell you guys, if you do not know how to factor this, I will tell you that please withdraw from this class, because this is something that is very simple. So if this is this, then what will be your answer for question 17? Just change all your x to become what? Sine x. So your answer in this case will be 5 sine x plus 2 and sine x minus 2. You guys all right with that one? Right, next is 18. Now, 18 is the one that is special. That's why I want to point out this is the one that a lot of students have in trouble, which is fine. I will teach you this one. And yes, this is coming up in your test on next week. So you better pay attention. Okay. Now, what is the difference between 17 and 18? 17, everything is in terms of sign. So you can factor directly like what we did in here. But for 18, they are not in terms of sign, because one of them is in sine and one of them is cosine. So they are like apples and oranges. You cannot factor them. So in order for us to factor it, they all has to be in the same term. Okay, so same trigonometric function. So so what we're gonna do here is we have to use Pythagorean identity to change your sine square x to become cosine. So as you know that Pythagorean identity says that sine square plus cosine square is equals to 1, right? So how can we change the sine square x to in terms of cosine?
Hopefully just a jump start.
By using the Pythagorean
Identity.
Yeah, identity.
So we just move the cosine square over. So what is sine square is? Sine square is actually is what?
1 minus cosine squared.
Yep. So that means this sine square will be replaced by 1 minus cosine square x. And then the rest, you just rewrite it plus 4 cosine x plus 11. And then you combine like terms, 1 and 11. Don't forget, class, these two are you adding it, you're not subtracting it. So what you get when you combine this? This is easy. You should know how to combine this. You get what?
12.
12, not 10. Again, I already told you just now, we are not subtracting, we are adding, because this is 1 plus 11. 12, not 10. Okay. Now, so does anyone know how to factor if you have a, now if you look at this, everything is in terms of cosine, so we can factor it. Does anyone know how to factor something that has a negative in front? So you got negative x squared plus 4x plus 12. Does anyone know how to factor this one?
You take yes.
You take the negative out, right? You factor the negative out. Do you know what happens when you factor the negative out? All your sign has to be
changed.
Yep. So the negative will become positive x squared, the positive 4x become negative 4x, and the 12 will become negative 12. Now with this, you can factor it. Anyone know what is a factor for this one? Yep. You got 2 minutes to factor this. Yep. Time to put in the chat room. I am so sorry. I don't look at the chat room quite often because I got a lot of windows pop up. This is even easier to factor. So make sure you know how to factor this one. So usually if I told my students, if you doesn't know how to factor the cosine square x, something like that, change it to x squared, like what we just did over on the right hand side here, because you know how to factor this. And then after that, you just replace it back to cos x. Alex is very good. So it's x minus 6 and x plus 2, right? Yep, x minus 6. And don't forget the negative. Very good. So your answer in this case, again, as what I told you, change all the x to become cosine x. So this answer will be cosine x, yep, minus 6. Now, thank you for putting parentheses for you guys. I saw Alex and they all put a parentheses next to the X here. This is for your online homework. Your online homework are very picky. They want a parenthesis on this X, but in the test, you do not need a parenthesis on it. Okay, so just say cosine X minus 6 and cosine X plus 2. But what else also you missing? If you just put like this, you get it wrong. What is missing here? Your negative, right? Forget the negative. So this is how you do this question number 18. You guys all right? Questions? So how do we know that we're gonna do factoring? Read the instruction. What's the instruction says? Factor the expression. So will you think I will use this instruction in your test if I want you to factor? The answer is yes. So in the test, I will use exactly the same instruction. If I want you to factor, I will say factor the expression. I will tell you that. So that means you factor it. Now, in number 19, we do not factor what we call, what they want you to do. They want you to multiply. So multiply means you have to void. So this question number 19, they have the form, the question is asking for 3 sine x. Okay, I'll do that over here. So question number 19 is 3 sine x plus 3 cosine x squared. Now, if students who doesn't know how to multiply this, you just do what is 3x plus 3y times 3x plus 3y. Because when you square something, you multiply it. I just changed my sine x to become x. I do my cosine x to become y. Does anyone know how to factor this one? Not factor, void. So when they multiply, they want you to void, not factor. Anyone? Voiding this?
3x times 3x.
Which is
9x squared. And then 3x times 3y, which is 3x, 3y, or 6xy, 9xy.
Okay, very good.
And then
thumbs up.
And then 3y times 3x, which is 9xy, positive. And then 3y times 3y, which is 9y squared.
And then combine like terms.
So 9x squared plus 18xy plus 9y squared.
Yep. Thank you, Samsung. Perfect. I think you guys know how to void this one, right? This is something you guys know. So what you need to do here is, this is the answer for it. But again, change all your x to become sine and change all your y to become cosine. So your answer in this case is 9 sine square x plus 18 sine x cosine x, because it's y, plus 9 cosine square x. This is exactly from here. I just changed back my x to become sine and my y to become cosine. Now, this is not done yet because we can further reduce it because of your Pythagorean identity that we have here. So what I can do here is I can take this 9 sine x and 9 cosine x. I can factor the 9 out. So what happens when I factor the 9 out? Because they all can be factored 9 out, right? So what I have in this case is sine square x plus 18 become 2 sine x cosine x plus cosine square x. Does the 9 become? So this is, and then we can apply our identity here, our Pythagorean identity, where the sine square x plus the cosine square x actually give us what?
1.
1. So your answer in this case will be 9. 1 plus 2 sine x cosine x. So these two combined using Pythagorean become 1. And then this, the 2 sine x cosine x still remain the same. So your answer in this case will be this 9, 1 plus 2 sine x cosine x. Questions with number 19. Now this is the, if you want to take a picture of this using your phone or something else, be my guest. This is how you do 17, 18, and 19 in your homework. Next, we're going to talk about is 21 and 22. You guys okay with pictures? Before I start a new one. Okay. Next is 21 and 22. So question number 21 is going to be use the fundamental identity to simplify this. Okay. So 5 tangent negative x cosine x. I think it's recorded. Yep, it's recorded. So, okay. Next, so what can you do with the identity in this case is first thing first, which identity can you apply here? Which identity can you apply for this question number? Sorry. I got a lot of things pop up here. Which identity can you apply? Anyone? On this question.
Even odd.
Even odd. Yes, you can use even odd because tangent this is a negative in here. So you can use an even odd here. So what happens if you see a negative using even odd? This negative disappeared, or does that move it up front?
Moves it up front.
Move it up front. So this negative will be moved up front. So the is gone. All right, next, what can we do next?
Quotient.
Quotient, yes, we will apply quotient here because tangent x can be replaced by what? Quotient of tangent x is what? Sine over cosine. And then the cosine is there. And what happens to cosine and cosine? They will cancel out. So what's your answer in this case? Negative 5 sine x. You guys all right here? So in my test, what will I come out in my test is, like to next week is, I will want you to prove 5 tangent negative x cosine x is equal to negative 5 sine x. So I want you to prove, and this is how you prove it. So in your test, I won't call you to simplify like what we did in question 21, but I will want you to prove it. Prove this is equal to that. Okay, and this is how you prove it. You guys all right? Next, the same thing. You have to simplify this. Cosine x secant x minus cosine x. So anyone know what identity should we use here? Anyone? I'm not doing work today. You guys have to do the work because I know what to do. Anyone what to do? This is not tough. I can tell you the answer. The answer in this case is sine square x. So my question is, how are you going to prove this? Because this is what you get in my test. This is equal to sine. So prove this. Anyone? There's a lot of, so I recommend not to put in the chat room because there's a lot. So tell me which one you're going to start first. Brianna? Henry? Reciprocal identities, very good, yes. So you use a reciprocal, oh, thank you, I didn't read this. So we use the secant x, change it to become, oh good, I didn't say it. 1 over cosine x minus cosine x, okay? And what's next? Very good, that's correct. So change the secant x to become 1 over cosine. And then what you do,
Multiply.
yep, multiply, distribute in. So what happens when you multiply cosine x with 1 minus cosine x?
Get 1.
2 will cancel, you get 1. And what happens when you multiply cosine and cosine?
Cosine x squared.
Cosine square x. Okay. Don't forget, cosine square x and cosine x squared are 2 different things. Okay. What is cosine square x? Cosine square x is cosine x times cosine x, like what we have. Cosine x squared is the same thing as cosine x times x. And these are 2 different things. You guys with me here? So make sure you put the square right in the middle of the. If you put the square on next to the x, means the x squared is the one that is. Then after you do the cosine. You guys all right? So what can we tell when you do 1 minus cosine square x? What kind of identity can you use next?
I can't even say it.
The Pythagorean identity.
Pythagorean, yeah, that's it.
Now, if in the test, now I do want you guys in the test to tell me what identity to use. But if you, again, for me, I like to use short form. So reciprocal identity, I use RI. RI is reciprocal. Quotient identity is QI. Pythagorean, PI. Cofunction, CI. And even odd, EOI. So easy, okay? Yes, you are right, Alex. So this is using the Pythagorean identity, PI. So this is actually is sine square x. Okay. So please, in the test, you do not need to write down Pythagorean. You can just write PI here. And you can write QI here. No, QI, RI, which is reciprocal identity. So I understand it. So you do not need to write the whole full thing. You guys all right with 21 and 22? Questions, anyone? Before we continue with 28. 28. Okay. Yep, this is good. You guys asked a good question. You guys good with this one? Good.
Yeah.
Okay, next, 28. Now, 28, they want you to do this without fraction form. Okay, see the what they want you to do. So they want to say no fraction form. So in order for us to do question number 28, we will multiply by its conjugate. So if a question says not in a fraction form, you don't want a fraction form, then you do the conjugate. You guys know what a conjugate is? Can someone tell me what's a conjugate for this case, the denominator? Anyone? Conjugate? What's conjugate stands for? Hello, you learned this in college algebra, conjugate.
Isn't it the opposite?
Yes. So what is conjugate of 1 minus cosine y?
1 over 1 minus cos.
1 minus cosine y, what is a conjugate?
Oh, 1 plus?
Yes, change the sign, 1 plus. So this is what you guys, and then the same thing on the top. This is fraction. Remember when you guys add fractions, if you multiply 5 on the bottom, you multiply 5, the same thing on top. So this is the same thing. We multiply the same thing on the top and the bottom. So what happens in this case is that this top one, you just written down as sine square y times 1 minus cosine y. You do not need to distribute. And I will tell you why we don't distribute. You can distribute, but then you end up factoring back. So we just end up not doing distributing here. Can someone tell me what happens when you multiply 1 minus cosine y with 1 plus cosine y? What do you get? FOIL it out. Samsung did foiling just now, so I'm going to pick someone else to do it here. Joanna? Joanna, are you there?
My iPad's being really glitchy. I think it'll come back and like reload. I can't really hear you very well.
Mm-hmm. All right, Katie? Katie, can you foil this? Wow. Don't tell me it doesn't know the 4a. Katie, are you there? Maybe someone in the chat room type. Katie? Katie, are you there? That's my aunt's question. Katie, are you there? Katie Casey, are you there? Not Katie, sorry, not Katie, Katie. Katie Casey. I'm going to call people's name now because if you're not there, I will kick you out from this class. Katie Casey, are you there? 5, 4, 3, 2, 1. Not there, we moved. Yep, that's easy as I'm going to do this now because if you're coming here, just turn it on and go do your other stuff. I will kick you out from this class now. Yes, Summer, that is correct. So this is 1 minus cosine squared y. Yep. And can you tell me, we did this now, this one, right? What is 1 minus cosine squared y if you use your Pythagorean identity? Using Pythagorean identity, this is the same as what? Sine squared, yes, this is the same as sine squared y. And that's why I do not want to factor and distribute the sine squared y on top, because this sine squared y and this sine squared y can be canceled. So what you get here is what? 1 minus cosine y. Yep, good. So that's your answer for question number 28. So your answer is 1 minus cosine. You guys all right?
Wait, how come on the bottom it's also equal to sine squared y?
Because you use Pythagorean identity here.
Okay.
Pythagorean identity says sine squared plus cosine squared equals to 1.
Mm-hmm.
So when you cancel out the sine square y and sine square y, you're left with 1 minus.
Yeah.
Where is it? That one. Okay.
I'm assuming that one took out of the, because you know how it's 1 minus cosine squared? Since there's another one, that's why there's one left, right?
No.
Squared?
Okay. If you move your cosine square over here, 1 minus cosine square is what? Sine square, right?
Yeah.
So this whole thing is sine square y.
Oh, okay.
And then the top one also has sine square y. You can cancel that. That's why this is a leftover. That's why the answer is 1 minus cosine y.
Okay.
I think it's Mr. I think it's 1 plus cosine y.
Yeah.
No, when you foil this, is 1 minus cosine square y.
I'm talking about the
sorry.
top.
Yeah, I am so sorry. This is 1 plus. You are correct. So this is 1 plus. So your answer should be 1 plus.
Yeah.
My bad. You are correct. This is 1 plus because when you do this, this is 1 plus, right? Yep. Thank you so much for pointing out that is 1 plus cosine. All right. So this is how we do question number 28. So the next one we're going to talk about is 31. So question number 31 is asking us to do this. 4 root 3 is equals to square root of 64 minus x squared, where x in this case is 8 cosine theta. So you need to figure out what is this. Let me see. Yep. And the thing is, the theta in this case is between negative pi over 2 to pi over 2, just in case we forget about that. So your theta in this case is between negative pi over 2 to pi over 2. Can someone tell me what quadrant is this? Negative pi over 2 to pi over 2. What quadrant is this?
A 4 and 1.
Thank you. Quadrant 4 and quadrant 1. That is correct. So first thing first is you can substitute this whole thing inside here. Like substitution. Okay, because x in this case is this. So so this is the same thing as square root of 64 minus 8 square cosine square theta. So I square both of this. So when I square this, so everything here is square. So what we left in this case is 64 minus 64 cosine squared theta. And then you can factor. What can you factor out between these two terms here?
64.
You can factor out 64, and what we left in this case is 1 minus cosine squared theta. And we did this a lot of time. Can someone tell me what is 1 minus cosine squared theta?
Would it be sine square theta?
Yep, it will be sine. So exactly the same thing we just did on that. So this is actually will become square root of 64 sine square theta. Now, when you take the square root, this 64 will become 8. This sine square theta will become sine theta. So your answer for this case, 4 root 3 in this case will be 8 sine theta. Oh my God. There you go. Questions? Now, next we're gonna figure out is what is sine theta here is. So as you guys know that this is equal, so 4 root 3 equals to 8 sine theta. So you divide this by 8. So this can be reduced to 2. So sine theta in this case is square root of 3 over 2. Okay. So a lot of students, they just put root 3 over 2 in here. You get it wrong. The reason why you get it wrong is because this 8 sine theta is in absolute value. Absolute value means that it can be negative and positive, because every time when you square something, for example, when you see x squared equals square root of x squared equals to 4, can someone tell me what x can be? If I want you to solve this, x in this case can be what? So a lot of people just cancel these two out. Oh, x in this case can be 4, right? Okay. And don't forget, you got two answers here. X also can be also negative 4. Because when you take a negative 4 and you square it, you get 16, right? And then you take the square of 16, you get 4. So that's why when you have this, you have what we call an absolute value, means that you'll have both positive and negative answer. So for the sine theta in this case, you will have 3 over 2, but you have two answers, positive and negative. And because of the quadrant, the positive is in quadrant 1, the negative is in quadrant 4. So that's the reason why that your sine theta in this case have two answers. One is the square root of 3 over 2. And then the other one is just the square root of 3 over 2. You guys with me here? Next, we have to figure out what is cosine theta is. So in order for us to figure out cosine theta in this case, you can figure out using your Pythagorean identity. Okay, so I'm gonna go to this page here because I have no room. So what do I do in this case is using Pythagorean identity. We have sine squared plus cosine squared is equals to 1. We know sine is the root 3 over 2. So it doesn't matter it's a plus or minus, because when you square it, it'll be gone. So when you square this is 3 over 4. Okay, root 3 become 3, 2 become 2, 4. And then plus minus is still positive, because when you square it, it's always positive. And then when you move the 3 over 4 over, you subtract 3 over 4. So in this case, c squared is 1/4. 3/4 minus 1 minus 3/4 is 1/4. And then when you take the square root, now when you take a square, you also have a plus minus. So your cosine theta in this case is going to be plus and minus 1/2, because 1 square root of 1/4 is 1/2. However, you cannot put plus minus here, like last time, plus minus here. The reason why is because of your quadrant. Can someone tell me cosine is positive in quadrant 1 and also in quadrant what?
3.
Cosine. Cosine is positive in quadrant 1 and quadrant
4.
4. Yes. So can you have a minus sign in here? You cannot, because of this domain bounded. So your answer in this case is just 1/2. The reason why you cannot take negative 1/2 is because of quadrant 1 and quadrant 4. You guys all right here? Questions? Okay, if you are taking calculus next semester, make sure you put an absolute value on this one. This is usually, that is what in calculus you will learn this. Okay, when you go to calculus, you put an absolute value. That means that this number here is always positive. The next question, the last question for this one is 32. So in question number 32, you have to use some ln property. Does anyone remember what you do when you have an ln when you add them? What's the absolute value? Anyone know what's ln A plus ln B? What is this going to be? College algebra? When you add, Kun?
ln AB.
A times B, right?
Yeah.
Yep. So when you add, you multiply them. And what happens when you subtract? You will divide. Yes. So the reason why we put this in absolute value is because, again, in college algebra, you cannot have ln negative. Does anyone remember what happens when you have an ln of a negative number? Is undefined. So that's the reason why they put this in absolute value, to tell us that this has to stay in positive. So for this case, this is ln. And because it's addition, so we will multiply this. So cosine x times tangent x. So can someone tell me which identity can be used to do simplify of this? Which identity can be used to simplify the one inside the absolute value?
Quotient.
Quotient, yep, because tangent can be written down as what?
Sine, cosine.
Sine and cosine, yes. Sine over cosine. And what happens to cosine and cosine? They can cancel out. So what you left in this case is ln sine x. And make sure that it is in absolute value. So your answer in this case will be ln absolute value of sine x. Close your parentheses and have. Oh, there's a lot of, yep. So so this is your answer in this case. Questions on 7.1. Next will be 7.2. Anyone have any questions on 7.2? Sally, you find that number? Yep, very good. Yep, you guys good. Yep.
No, I'm good.
You're good? All right, anyone have any questions on 7. Yep, Alex, you are correct. Sorry about that. Anyone question for 7.2? Now, I want to point out to you guys that when you guys do 7.2, this is what we call as verify the identity. Do you think you get this kind of questions in your test next week where you fill in the blanks? No. I just want to point out to you in the test, it will look something like this one. It will look something exactly like this. You will say, I want you to prove 2 cosine x plus 2 sine x tangent x equals to 2 secant x. That's it. There is nothing like what you see here. Oh, all this blank spot here. So class, if I want you to prove this or establish the identity, pay attention. This is very important. You have to first tell me where do you start from? Is it on the left-hand side of the equation or the right-hand side of the equation? So where do you start this from? Left or the right?
Left.
Left. Okay, so you use LHS, just telling me it's from left-hand side. Now, another question I'll point out to you. Can you do something like this? Oh, I'm gonna subtract, let's subtract 2 cosine x here. And then let me divide everything here by 2. Can you do this, class? Can
No.
you do? No, you're correct, Samsung. So I want to point out to you guys, this is called solving. And it's not the same as proving. So if I want you to prove, but you solve, like this is solving, you minus and you divide and do this, you will get a big fat 0 in your test. I do not need to grade, I give you 0. Okay, so make sure you guys know that when I say prove it, you cannot do all this solving piece like divide and adding and subtracting, all these things that you guys do. You have to do exactly this to that. So let's concentrate on the left-hand side. So what can you do with this one? Anyone? What identity can you use? It's mostly all identity here. You want to know what identity to use?
Quotient first.
Quotient. So this is quotient. Yep. So you still have 2 cosine x plus 2 sine x of what? Anyone know what to do with tangent? Sine x.
Over.
Would it be sine x or cosine x?
Yep, this is correct. Now what do you do next? Don't forget, we need to get 2 secant x here. Anyone?
And then cancel 2 cosine x with the, like you cancel cosine.
You cannot cancel this one with this one. You cannot cancel this one. No.
Would you distribute the 2 sine x into the tangent?
So you will get 2 cosine x plus 2 sine x squared, because that's two of them, right? Over by cosine x. Yep, that's good. Okay, you cannot cancel the cosine because this is addition, because that's 2 separate terms. Unfortunately, you cannot cancel these 2 because they're not the same. What else you can do here? This is what you get in my test next week. Do you guys know how to add fractions?
Yeah.
Find the LCD, right? So this is over 1. So what's the LCD here? Yep, cosine x is the LCD. You're correct. So you need to multiply this one by what? Cosine x. This one also has to be multiplied by cosine x. Do we need to multiply anything on the last one? No, because we have cosine x. So your denominator is cosine x. So what you get on the top? 2 cosine square x plus 2 sine square x. Anyone know what to do next?
Do you like write the cosine into 2 parts?
No. What can you do on the top one?
Would be one with the PI identity.
Yeah, PI. So the 2 you can factor out because these 2 have 2. So you can factor the 2 out. So you will get cosine square plus sine square all over by cosine x. And what is, and as what, is that Sally or someone else says? This is PI. And what is cosine square plus sine square? This is exactly
Yep, it's 1.
1. So this is 2 times 1 is 2. So it's 2 cosine x. But don't forget, my proving here is 2 secant x. So what you do next? Last one. This is easy. What kind of identity we use?
Reciprocal.
Yes, reciprocal. You are correct, because this is 1 over cosine. 1 over cosine is the same thing as what? Secant, right?
Secant, yeah.
Yep, so that's why you will get 2 secant x, which is the same thing as your right-hand side. So this is how you prove an identity. So I see a lot of students, they do left-hand side halfway, and then they stuck, and then they start on the right-hand side halfway, and then, oh, they are the same. No, you cannot do that. So something like this, I will give you another example. You will see some students, so do not do this in your test. You do left-hand side halfway down, and then you get, let's say this, 2 cosine square x, something like that. And then you start on the right-hand side, and then you do halfway there, and you get back the same thing, 2 cosine square x plus 2 sine cosine x, and then you just leave it like that. In your test, you get half a point. You get half of all the points. Let's say if this is a 5 points, you get only 2.5 or 3 points in your test. So make sure you start on one side and you have to finish all the way till the right side. You cannot start halfway there and then, okay, I'm stuck. Let's start the other halfway there. No, you will get only half a point in this case. Questions? You guys? And you can always change this beta. If you don't like beta, you can change it to X. Okay. Let's do another one because this is something that I really want you guys to do in the test, because in the test you will get these kind of questions and without any blanks like that. Okay.
So I guess my only question is how do you decide what piece you start with?
The one that you mean the left or the right?
No, I mean like if it's like the sine tangent, which one do you work with? It's
up to you. So this is something that I want to tell you that I cannot teach you. You have to think outside the box and you have to start working on it. So they are factoring. You can multiply by the conjugate, use the identity. So there's a lot of things that you guys can do, foiling it. Okay, so I cannot teach, I mean, you have to practice, in other words. So like question 12, should we start from the left or the right?
Left.
Okay, so can someone tell me how do we start from the left? And don't forget, we need to get secant theta here. Yeah, this is how the questions will come out in your test. And class, as I told you, I cannot teach you this, you have to practice.
The bottom part equals to, actually no.
Not square. You cannot, it's not square, you cannot use Pythagorean.
Should we multiply by the same thing?
Not the same thing. We always say what? By its conjugate, right? Anyone wants to guess what to do? Don't look at me. What Sally say is I will tell you the same thing. I do not know what to do first. You have to try something first. So someone wants to try something, use identity.
Don't we have to change the secant to 1 over cosecant?
Okay, very good. So we're going to use Ri. Yes, you can do this. So we're going to use Ri on this one. Very good. It's no wrong. It's just that you have to try it. And make sure you, class, use pencil to do your test.
Use what?
Pencil.
Oh, okay.
Don't use pen because you'll be very horrible. All right. And make sure you make some room. Don't squeeze everything into 2 lines if you write it down. You make more rooms there. Anyone know what to do? I changed the secant to become reciprocal, 1 minus cosine. Anyone know what to do next?
You have to multiply it by the denominator.
So you want to make this the same LCD because you're adding, subtracting fraction. So what is the LCD for this case? This is 1 over 1. So what's LCD in this case?
Cosine.
Cosine. So you have to multiply this one by cosine, right? So what we have on top here is what? 1 minus cosine theta over cosine theta. And this is all over by 1 minus cosine theta. This is, the denominator is fixed, you cannot mix it. What next? Yep, this is correct. You multiply this to make them the same. Does anyone know what to do when you divide with fraction?
Multiply the reciprocal.
So you multiply by its reciprocal. This is over 1. What's the reciprocal of this? It becomes what? 1 over by 1 minus cosine theta, right? What can you do with this 2 when you multiply? Can we cancel something?
1 minus cosine.
We can cancel those 2 up. So what you left?
1 over cosine.
And what is 1 over cosine theta is using
Secant.
RI. This is secant theta, which is the same thing as your right hand side. This one. I can tell you right now is this is all from you guys. I didn't do a lot of work, so you have to, this is a lot of practice. And if you guys say, I want more practice, yes, you can get more practice. You just go to your homework, your textbook, go to 7.2. If you got your ebook or something else, go to 7.2, chapter 7.2. There will be a lot at the back of the exercise of 7.2. There is a lot of this. So you go 7.2 exercise, 7.2 exercise. All this, see that? And if you click on the answer, they won't give you any answer. Why? Because the answer is right to the next to it. So that's the reason why if you're proving things like this, yeah, practice this. There are tons of this question. Look at that. There are like 40 some, 50 some proving here. Verify the identity. This is something I do not do. If you see anything with square root pop out, just ignore it. So don't do this. So start at number 54. I recommend if you want to try, start at 54. That's a lot. If you can manage to do a few of this, I'm very happy with it. Should we tackle a few more?
Yes, please.
So let's do this one, number 24. Cosine x minus cosine x over by 1 minus tangent x. And this is equals to sine x cosine x over by sine x minus cosine x. This is number 24. Anyone wants to start first? Left or right? In your test, tell me, left or right?
Left.
Okay, so we start from the left-hand side. Anyone know what to do with the left-hand side here? How do we add or subtract fraction? This is fraction. How do we add and subtract fraction?
You
Find
make the denominators the same.
What's LCD? So find the LCD here. 1 minus tangent x, right? So this has to be multiplied by 1 minus tangent x. Yeah, this is something that I will tell you that So what happens when you distribute this? Cosine x times 1, you get cosine x. Cosine x times negative tangent x. Can someone tell me what happens when you take cosine x times with negative tangent x? Tangent is what over what using quotient?
Sine over cosine.
Sine over cosine. And what happens to this cosine and cosine? They will cancel out. So what we have is a negative sine x. And then you have minus cosine x. Okay, so how many cosine x do we have in this case? Oh, the cosine x and cosine x will cancel, right? So this one and then the negative cosine x come from here. And this cosine x and this cosine x will cancel. So what I left in this case is negative sine x over by 1 minus tangent x. But this is your right hand side, this one, completely different. So can someone tell me what can we do next?
Qi to the tangent.
Very good, because you find out that this right-hand side is all in terms of sine and cosine. So that's the reason why that we want to get this in terms of sine and cosine. So we will use the Qi. So this is 1 minus tangent is sine over cosine. Then what to do next?
You find the LCD for the bottom two.
Yep, find the LCD bottom. So your denominator is cosine x. So you have to multiply this by cosine and cosine. So what you get here is cosine x minus sine x, or negative sine x. What you got next?
You multiply by the reciprocal.
So minus sine x times flip-flop this. Cosine x over cosine x minus sine x. So what you get? You cannot cancel because there's nothing can be canceled here. So the top one you get negative sine x cosine x. But the bottom one you get what? Cosine x minus sine x. Is this the same as your right-hand side?
No.
No, because you have a negative here, and this is switched around, right? So you can apply the negative to the bottom. So what happens when you apply the negative to the bottom? You will get sine x cosine x over by, do you know what happens when you multiply negative to these two? You become sine x minus cosine x, which is the same as this side. Tough?
Wait, I have a question. How come you applied the negative to the bottom? Is it -1 over -1?
Can you put the, if I have -1, so can I apply the negative? Is this the same as 1 over -2?
Yeah.
I just apply the negative to the bottom.
Okay.
So like this is the same thing. So your negative can move around, right? You can put in the middle, you can put in the right top, or you can put in the bottom. So I just move it to the bottom in this case.
Okay.
Yes. We have levels. Like how difficult is this? This is like level 4, the one that I'm doing right now, this 24 here. This is level 4. That means quite difficult. This one is probably level 2 or level 3. The one that we did here is level 2, level 3. So in the test, you will get a bit difficult one. You can tell by the points. This one, if it's a level 4, it's going to be 5 to 6 points. Level 2 and level 3, usually 4 points. So the more points you see next to the proving, the more difficult it gets. So that's why I tell you that, can I teach you? You have to actually learn it yourself. So that's the reason why I really, really want you guys to do this. Usually in your homework, if you do this, the first 2 is easy and then okay, moderate, and then these are difficult. Usually, okay? Like this is easy and then moderate and then tough. So you can tell. So I recommend you to practice this, very important. Now, the next thing we're going to talk about in today's class is 7.3. This is the very last section here. This is solving equation. So last time when we do is proving. So proving you cannot solve. Now we are solving. So solving you solve. So how do we solve this is you solve an equation. Like example is, I'll give you some homework here so you can look at it. Example is, and this homework is due on Monday, not Wednesday. Okay. So if you want to have a Zoom on a Monday class, next Monday to talk about 7.3, be back. Let me know. Okay. So for this one, you just plug it in. Okay. Remember last time when you solve equation, you figure out if x is the answer, you substitute x into it. So what you do here is x pi over 3 is a solution to this. You just plug pi over 3 inside here and check if you get 0 or not. If you get 0, good. If you didn't get 0, no good. Make sure you put this in radian. Okay. So like question number 5 that we have in this case, So when you guys want to solve, you
By
have to.
tomorrow, I will cry. Like 3 of them. If there is 3.
I'm
I will-
sorry. Anika, you got a question? Anika,
What?
you got a question?
Oh no, sorry.
Can you can you type present for your attendance? Attendance time, please put present. Okay. Now, you guys know how to do present attendance, right? Attendance time. I want you guys to know that one thing. I want you guys to read the instruction here. It say solve the equation. Again, everything is in radian. So when you guys do your test or your homework, your answer for this chapter 7.3 is all in terms of radian. So I won't take 60 degrees. I will take pi over 3. Okay. Now, there are 2 types of solution that we have. One type is just say solve the equation. The other type is find the solution in the interval from 0 to 2 pi. So what is the difference between question 7 and question 8? Okay. So this is something I will point out to you guys. If you for question 7, if there is no interval from 0 to 2 pi, then your answer, you just need to add 2k pi or k pi. Depends on your trig. So if you have tangent or cotangent, you just add k pi. The reason why you add k pi for tangent cotangent is because the period for tangent cotangent is pi. So that means you just add k pi. But if you have the other rest of it, sine, cosine, secant, cosecant, then you have to add 2k pi. So for example, if you find your answer is pi over 3, then it's pi over 3 plus 2k pi if it's sine, cosine, secant, cosecant. Otherwise, it will be pi over 3 plus k pi if it's tangent or cotangent. So this is your if you doesn't have 0 to 2 pi. But for question 8, if you have 0 to 2 pi, now be careful with this. This is bracket and this is parentheses. Do you guys know what's the meaning of this? It's an interval.
They're not included.
Yep, it includes 0 but cannot include 2 pi. So when you have this, then you have to learn, you have to use that, the one that you learned in chapter 6. All students take calculus, and you can only go for 1 revolution. Okay, so the difference is if I give you 0 to 2 pi, you can only go 1 revolution. But if I didn't give you 0 to 2 pi, like question number 7, then this goes infinite revolution. And for infinite revolution, we use the 2k pi and the k pi in this case. In your online homework, they don't use the k, they use n. So I just changed 2n pi and n pi. Sorry about that, because they want n, not k. So I don't care in my test, k or n. So if you look at question number 5, which one is this? Is that going to be 1 revolution or is that infinite revolution on number 5?
Isn't that just 1?
No. Do you see 0 to 2 pi?
Oh.
So this is infinite. This is this one. Okay. Until they say 0 to 2 pi, there is only 1 revolution. So how do we solve this? How you get x by itself here? Solving. Which one should you get rid of? Tangent or root 3?
Do root 3 first.
Move the root 3 over there, right? So tangent x in this case is square root of -3. And then you move the tangent over, right? So you will get the arctangent of -√3. So now you have to figure out what is this value is. And how do you figure this value out? You have to use your unit circle. Remember your unit circle? So can someone tell me using the unit circle, tangent is y over x, right? So which one of these, when you divide, will give us square root of 3? Y over x. Do this give us square root of 3? Which one will give us 30, 45, or 60?
60.
60 degrees. But as you guys know that we want this in radians, so this is pi over 3, right? But this is just for square root of 3, but I want a negative square root of 3. So what was that going to be? Anyone? What quadrant is this going to be if it's negative?
4.
4 or quadrant 2, right? Because 2 and 4 is negative for tangent. So can someone tell me what is your answer for quadrant 2 for 60 degrees?
2 pi over 3.
So this will be
And-
2 pi over 3.
And 5 pi over 3.
And 5 pi over 3. Now, if the question is asking us from 0 to 2 pi, this will be your answer. But since this question wants us infinite, so your answer in this case will be 2 pi over 3 plus n pi. Okay. The reason why we did not include 5 pi over 3 plus n pi here is because if you look at the unit circle, this is 2 pi over 3, right? Do you know what happens when you add 180 degrees pi? You will end up with what? 5 pi over 3. And if you add another pi, you end up with 2 pi over. So what happened is that for tangent, it's very special because if you want to go from quadrant 2 to quadrant 4, you add pi. That's why, and then you add another pi, you add another pi. So when you guys do for tangent case, you do not need to worry about 2 answers because once you add pi, you go to quadrant 4. And then when you add pi again, you go back to quadrant 2. So you only need one answer if it's tangent. And that answer in this case will be 2 pi over 3 plus n pi. Tough?
Could you repeat what you said earlier about like why tangent only needs one answer?
It's because if you look at your unit circle, if we know tangent is negative in quadrant 2 and quadrant 4, right? So if you look at 2 pi over 3 and 5 pi over 3, if you add 180 degrees, or which is pi, you get back to quadrant 4. Exactly. See that? And then you add pi, 180 degrees, you get back to 2 pi over 3. So what happens for tangent or cotangent, because they're the same, if you have, we know quadrant 2 and 4 is negative for tangent, and 1 and 3 is positive. So what happens is you just need to add n pi in this case. You do not need to worry about taking the quadrant 4 and do it again. Okay, this is only happens for what? Tangent or cotangent. So for number 6 is a little bit special. So we got 7 cosine x plus 4 equals to negative cosine x. So how do you solve this equation? Anyone? It's an equation. How do you solve this? How you solve 7x plus 4 equals to negative x? You should know how to solve this one, right?
-4 both sides.
-4 both sides, okay. So this is gone. What else? Like this one, how do you solve for x here?
Plus cosine.
Yep, you need to plus cosine. This is gone. So what you got?
8 cosine x equals to -4.
So what you do next? Divide this by 8, like solving, right? So cosine x is what?
-1/2.
Negative half. And then we move the cosine x over. Do you know what happens when you move your cosine x over to the equation? Like tangent, we move over, become what? Tangent, arctangent, right? So this become what?
Arc cosine.
Arc cosine of negative 1/2. So now let's read question 6. Is question 6 want us to write your answer as 0 to 2 pi, 1 revolution? Or does it want for you to infinite revolution? This is question 7. 6. Infinite, because they don't ask for 0 to 2 pi. So if it's infinite, means that you have to figure out what is this one. You have to use the 2n pi in this case, because we're using cosine. So can someone use the unit circle approach here to tell me cosine is what, x or y?
X.
X. So can you tell me which x coordinates here give us half?
Pi over 3.
Also pi over 3, 60 degrees. But this question does not want half. This question wants negative half. What quadrant can you tell me cosine is negative?
2 and 3.
2 and 3. Can you tell me what is quadrant 2 for pi over 3 or 60 degrees?
2 pi over 3.
2 pi over 3. And how about quadrant 3?
4 pi over 3.
Yep. Now, because this is cosine, so your answer is 2 pi over 3 plus 2n pi, and 4 pi over 3 plus 2n pi. So this is your answer for question number 6. So you have 2 answers. Okay, and I want to point out again, for sine, cosine, secant, and cosecant, usually you will have 2 answers. But for tangent, the n pi, you only have 1 answer. Okay, because of the quadrant location. You guys want to try number 7? 7. 3 cotangent square x minus 1 equals to 0. So this is the same thing as 3x squared minus 1 equals to 0. Do you know how to solve this one? How you solve for x for this one? Anyone? What do you do? Do the same thing to him. Anyone know how to solve this one? Hello, anyone know how to solve this one?
First, you have to add the 1 over on the other side.
And then?
Divide it by 3.
Yes.
And then square root them.
And when you square it, what you do? You have to put plus and minus, right?
Yes.
Can someone reduce square root of 1 over 3? You have to reduce this.
1 over square root 3.
How about rationalize it?
Square root 3 over 3.
Very good. Don't forget the plus minus. So this is the same thing. So you just add 1 over here, divided by 3, that's what you just did. Take the square root, plus and minus. So this is actually cotangent x equals to plus minus 1 over 3, which will become root 3 over 3. The same thing we just did over here. We just do it here. And then now what you do next is move the cotangent over, become what? The arc cotangent. So this is plus minus. Do you guys know what happens when you have plus minus? What quadrant it belongs to when you have plus minus? All 4 quadrants. Okay, all 4 quadrants. Because plus minus for cotangent is 1, 2, 3 is plus, 2, 4 is minus. So plus, if you got plus minus means you're talking about the whole 4 quadrants. But for cotangent is special because if you did if you know quadrant 1, if you add n pi, your answer will bounce to quadrant 3. So this will take care of the positive one. The negative one we know is quadrant 2 and quadrant 4, right? So once you find out what is quadrant 2 answer is, if you add n pi, it will bounce to quadrant 4. So your answer in this case have to be in quadrant 1 and quadrant 2. Quadrant 1 is for positive, quadrant 2 is for negative. So let's figure out quadrant 1 first. So how do we figure out? Again, unit circle approach. So can someone tell me cotangent is what over what? X over y or y over x?
X over y.
X over y. So can you tell me if you take x over y, when you divide these coordinates, which one of these give us root 3 over 3? 60, 45, or 30?
30.
30? X
60.
over y. Again, class, I want to tell you your answer is either 30, 45, or 60. Use not other answer. So which one again? 30, if you take x over y, you get square root of 3. So your answer is what? 60. Okay, don't forget, cotangent is x over y. So when you do this divided by that, you get 1 over root 3, which is the same thing as root 3 over 3. So your answer in this case will be pi over 3 plus n pi, because this question does ask us from, doesn't tell us, it doesn't go from 0 to pi. And what happens to quadrant 2? Anyone know what's quadrant 2 for 60 degrees or pi over 3? It'll be 2 pi over 3 plus n pi. So your answer is these two answers. And the reason why we got these two answers is because one of this is for the positive and one of this is for negative. You guys with me here? Questions before we go on the last?
If we have a square in the first part of the equation and it's not a cotangent or tangent, we would have 4 answers, right?
Oh yes, if this is, let's say, is sine, then your answer will be quadrant 1, quadrant 2, quadrant 3, and quadrant 4.
Okay.
And they all will be 2n pi. Yep, you are correct. Yep. So if this is sine, not tangent or cotangent, if it's sine, cosine, secant, or cosecant, then your answer will be this plus, so it will be 4 pi over 3, and then 5 pi over 3, let's say. You will have all 4 answers. Because 2 of them will be positive, the other 2 will be negative. You guys good? That's good. You guys catching it. You guys all right? Tough? Yeah. And do you need unit circle approach? Oh yes, unit circle approach. Now, the only thing about question 8 is different from the rest of the question we did so far is because question 8 doesn't want us to be infinite. Question 8, they want you in how many revolution? You need into 1 revolution. Okay, only 1 revolution. So can you solve an equation with 2 different trigonometric functions, sine and cosine? The answer is no. You cannot solve like this because everything you solve has to be either all in terms of sine or in terms of cosine. So can someone tell me what can we do here to change everything in terms of 1 trigonometric function? You learned that.
Pythagorean?
Yes, we use Pythagorean. So which one you want to change? Let's change cosine square x. So can someone tell me what is cosine square x using in sine?
1
minus sine.
Yep, 1 minus. You guys are good now. Yes, very good. So what we do here is we divide, we multiply the 3 inside, we distribute. So we got sine square x equals to 3 minus 3 sine square x. Anyone know what to do next?
minus 3, I mean plus 3 sine.
Yep, plus 3 sine square x to get rid of him, right? So how many sine square x do we have in this case?
4.
4, because 3 plus 1 is 4. Now, how do we solve for x here?
Divide by 4.
Divided by 4, very good. Followed by what?
Square root.
Square root it, very good. So when you square root this, you got plus minus, right? Can someone help me to reduce this square root of 3 over 4? Anyone?
Square root of 3 over 2.
Very good. This is root 3 over 2. And then you move the sign over, so it'll become outside, the inverse. Can someone tell me how many answers do we get here? How many answers you get? Now don't forget, we want it in one revolution, so you do not need to worry about the 2n pi or all these things. How many answers you will get here, class, when you get this?
4.
4, very good. Because plus minus give us quadrant 1, 2, 3, 4. But if you know quadrant 1, 2, 3, 4 is the same reference angle. So sine, if you look back your unit circle here, sine is x or y value. Sine is
Y.
Y value. Can you tell me which Y value, which answer here is going to be root 3 over 2? Again, is what? 60.
Yeah.
Yep. So we pi over 3. But as you guys know that it has to be 4 answers. So pi over 3 is in quadrant 1. Can you give me the other 3? Two pi over 3, which is in quadrant 3. 2, what else?
4 pi over 3.
3, and also what? 5 pi over 3. So these are your answers you put into question number 8. You guys okay here? So what is the difference between 7 and 8? Is 8, your answer is just no n pi, okay? But once you see question 7, it doesn't have anything, it will be in n pi. So in the test, which one will I ask? I will ask one question looks like number 7, where you need to put in n pi or 2n pi. And then one is like number 8, where you do not need n pi, you just give me your answers. And can someone tell me why you have 4 answers in this case?
Because of the plus and minus.
Very good. Do you know what happens if students forget to put plus and minus when they take a square root? This is a common mistake. This is what you get in my test. A lot of students forget to give me plus and minus. Do you know what happened? You got how many answers if you don't have, if let's say your answer is just root 3 over 2. Let's say you just got root 3 over 2. How many answers you will get?
2.
2. Which 2 answers? Out of these 4, which one of these is positive for sine? Quadrant
1 and 2. So pi over 2.
Yep.
And 2 pi.
This 2 will be for sine, for positive, and this 2 is for what? Negative. So make sure you guys be careful when you take a square root. Make sure you put a plus minus on that side. Anyone have any questions here so far? So I didn't finish this. This is something you will need to do. Sometimes you need to factor, like question 11. You have to change this sine square x to become cosine, like what we just did over here. You change it 1 over cosine square x, and you require to factor them. Okay, and once you factor, you will solve it. Let's say your factor is cosine x minus 1 and 2 cosine x plus 1. Then you get cosine x in this case is 1, and then cosine x in this case is negative 1/2. Like solving, when you factor, and then you move the cosine over, become arc cosine, and then you use your unit circle approach to figure out which one is cosine. Can someone tell me what arc cosine you get 1 using the unit circle approach? It's a special one. Cosine is x or y?
X.
X. So can you tell me which x value here is 1? What angle is that?
0.
0. So this is 0. Can we use 2 pi? Because this is also 2 pi, right? Can we use 2 pi? Based on our domain restriction, 0 is included. That means it's good. 2 pi, is that included?
No.
No, so you cannot use 2 pi. Okay. Can you tell me also, when you do the arc cosine of -1/2, which one of these give us arc cosine of -1/2?
2 pi over 3.
2 pi over 3, and also what? Which is this one, -1/2.
And
4 pi over 3.
4 pi over 3, yep. So what is your answer in this case? If you got something like that, your answer would be 0, 2 pi, and 4 pi over 3. You guys all right? Now, as I mentioned early on, can you use this unit circle in your test?
Yes.
Yes, but can you have all these little things on it?
No.
You are correct, Sally. So it's only a blank unit circle. So when you take, let's say today is a test day, if you are using this, you have to enable your camera and show it to me. I want everyone to show me the unit circle, and the unit circle should be black, a circle like this with no coordinates, no numbers, no that sine, cosine, theta. It's just that degree and the radian and the circle like that. You guys with me here? Please print that out. I think I posted in D2L. You get a copy of it in D2L. Otherwise, I'll send a blank copy to you guys later today. So please print that out, and you can use that in your test. So you cannot fill it out. That's it for today. Anyone have any questions for me before I go on to the next Zoom meeting? Stop sharing here and start recording.